We're good? Okay. All right, we'll get started. Good morning. My name is Ryan Black. I work with Dave Jones out of the Madison area. We cover Milwaukee as well. So some of you may have heard of us before. Just give you a little background, I guess, on myself. I've been in the HVAC industry for 15 years. Originally grew up in northern Wisconsin, so I'm kind of an import as of the last few years. My family moved down to just outside the Madison area about 2 years ago. So I work for a service company in northern Wisconsin, dealing specifically with HVAC, service, new installations, design work, so on and so forth. So, and currently, I'm a project manager, HVAC estimator for Dave Jones. So ranging anywhere from, standard 1,500 square foot ranch homes all the way up to, I just bid a 20,000 square foot custom house a couple weeks ago. So very broad range as far as my skill sets. And so today we're just going to kind of walk through, I guess, the basics of HVAC and some things to consider during the building process. All right, so in regards again to HVAC systems, one of the most crucial things during the design work of a home is to have the equipment properly sized. So load calculations, manual J CFM calculations performed in every home. Who here knows what a manual J is? Anybody? No? So manual J, what that basically is there, it's a brief description of an HVAC system for the house to determine proper BTU load. So what's taken in consideration with the manual J is square footage, insulation factors, direction that the house is facing, size of windows, quality of windows. So there's a lot of things that actually go into that manual J calculation. So, and why I make that as an example is you could take a 2,000 square foot ranch and have it average insulated. It might need, say, a 60,000 BTU furnace. You can take that same 2,000 square foot home, have a really good insulation package, really good windows, really tighten up the envelope. We might be able to drop that BTU load to 40,000 BTUs. But without actually doing a manual J calculation to determine that BTU load, we're simply guessing. Now I'm sure, in the new construction world and even in the service world, homeowners don't want you to guess to determine the proper BTU load of your home, both for the heating or the cooling, right? So manual J calculation is extremely important. One way that we do that working with builders for optimum equipment locations also is extremely important. During the new construction aspect, to place the furnace as centrally located as we possibly can makes a big difference on performance, makes a big difference on how the actual home heats and cools. If you have the furnace tucked in behind the stairwell and there's a bunch of jumpers that have to get around to make it around the stairwell, well, that's not going to be a very efficient duct system, right? So we try to place that furnace as centrally located as we can without, of course, mucking up the basement for a potential future finish. Furnace and AC run times as well. That's extremely important with properly sized equipment. And I'll make the example, highway driving. So you want to make sure that your furnace runs for a longer period of time. The longer that furnace runs, the more efficient it is, the more comfort your home is going to be able to be producing. And again, that highway driving is the example, is that if you can go down the highway at 70 miles an hour, you're going to get your best fuel economy that way, versus stopping and starting, say with city driving as an example. So, and what that would mean is that the furnace is too large for the house. So it heats up super fast, and then it shuts off. Or it cools super fast, and then it shuts off. So you lose some of the benefits of that heat distribution or cooling distribution by having that system too large. Again, getting back to it, the only way to determine that would be to do a manual J calculation. The other thing that it also affects is the longevity of the furnace and the air conditioning system. Does anybody know what the average life expectancy is of a high efficiency furnace? Any guesses? 20 years? 15? What did you? 15? Focus on energy states anywhere from 12 to 17 years if it's installed properly. So pretty darn close. That depends on, of course, climate as well, but state of Wisconsin averages 12 to 17 years. Now certainly there's furnaces out there that are much older than 17 years, but on the other spectrum, there's a lot of furnaces out there that might only make it 5 to 8 years. So part of that is we want to make sure when installing the equipment that the longevity is going to be there to give that homeowner the best value for their dollar. Because of fact, again, if the furnace isn't sized appropriately, that longevity of that piece of equipment is going to be cut in half because it's going to be running in a conditioned area where it's not set up to run properly. It's really set up and designed to fail. Some of the things that are also factored into the equipment sizing and how important a CFM calc and a manual J calculation is equipment SEER rating. It's determined by the sizing of the duct system and the refrigerant charge. Who here knows what SEER stands for? Anybody?
Seasonal energy efficiency rating.
Very good. Yep, and that's the efficiency of the air conditioning system. So typically you'll see that in a number like 13 SEER, 14 SEER, 16 SEER, so on and so forth. Basically what that means is the higher that SEER rating is, the higher that number, the higher the efficient that the system is. One thing to note here that is pretty astonishing, oversizing occurs in nearly half on new installations in the country today. Over half. So a lot of the reasons and a lot of things that are set in place in Wisconsin, which are really good, is there's inspections and a res check or a REM rate or a manual J needs to be completed on that home before a permit is even pulled. So that's a good way that protects Wisconsin, certainly protects the builders, protects the homeowners as well to make sure that they're getting a good producing system. But not all places in the country require that. Improper duct systems are a large attribute to poor performance as well. Just like a furnace, if the system isn't sized appropriately and the ductwork is too large or too small for that matter, the system isn't going to be able to breathe. It's not going to be able to get rid of the heat. It's not going to be able to get rid of the cooling that it needs to provide and keep the comfort in the home. By correcting these problems, ensuring that the system is sized appropriately, both on the equipment side as well as the ductwork side, can reduce peak air conditioning demand by 14% in existing homes, so from a service aspect, or up to 25% in new construction. So if you told your homeowner that by doing the things that you do, doing a manual J, doing a res check, that you can guarantee them a savings of 25%, that's going to mean a lot. It's a lot of energy efficiency that could be potentially lost without having that. And as far as maintenance goes, proper maintenance and installation, that can cut 24% in existing construction and up to 35% in new construction. So it's really showing how important it is on the front end to ensure that the system is sized appropriately, installed correctly. It's all in the setup, it's all in the beginning. So we've talked about this a little bit as well, but now we're going to get back into the importance of proper duct sizing. Has anybody here ever designed a duct system before or had any experience with that? A little bit? Okay. So getting back to how important it is to ensure that the equipment is sized appropriately. Some contractors' remedy for poor airflow is to oversize that equipment. I've seen it and heard of it that the house isn't performing, it's not heating or cooling properly. A lot of times the fix for that is to install a larger furnace or a larger air conditioning system to remedy that poor airflow and that poor performance. When in all reality, it might be the installation, it might be the ductwork, it might be the initial setup that's causing that system not to perform properly. flexible ductwork. Does it work? Does anybody have any experience with flexible ductwork at all? Insulated flex?
Certainly use on commercial jobs all the time.
I've got a couple of slides showing some of it in a residential application as well. But flexible ductwork, there is a law that's kind of being tossed out there right now that there's a good chance that flexible ductwork is going to be phased out, or at least reduced enough where it can only be up to 5 feet of length instead of running, say, 30 feet in an area where it's conditioned. An attic is the most common installation for that. If you had a duct system up in an attic and you had flexible ductwork stringing off, what they're going to force HVAC contractors to do is to insulate all hard pipe ductwork and not have any insulated flex. So obviously, oops, sorry, go ahead.
The reason for that is that the air isn't getting through that flex like it should?
Correct. Exactly. Flexible ductwork, if installed properly, flexible ductwork actually has a really good place in the industry. If it's installed properly, if it's not over a great length of ductwork, and it's installed properly, flexible ductwork, again, can actually perform pretty well. But what happens is typically flex is used to be able to chase up, say between that 2x4 wall, you're trying to chase up a 6-inch heat run up between a 2x4 wall, and you're crunching that flexible ductwork to try to get it up to that second floor. So obviously we're crunching that, we're reducing the amount of airflow, the amount of CFM that that particular heat run can provide, but still passing inspection because it's installed properly.
The common sin for residential is the 4-inch flex for the bathroom exhaust fan, right?
Correct.
And what I've been speccing is 6-inch insulated flex, and you keep it not more than 10 feet long
Sure.
before it connects to a rigid duct.
Right. Yeah, the maximum length that it's supposed to be is up to 14 feet of flex. So if you're over that 14 feet, again, the boxes come in a 25-foot section. So a lot of times a bath fan can run longer than 25 feet, right? So to make sure that we're keeping that up to 14 feet to meet that code requirement, yes, hard pipe would need to be installed on top of that.
But I'm upsizing it from 4-inch to 6-inch to better increase the airflow.
Yeah, you're probably seeing a lot higher CFM ratings on your bath fans than you would compared to 4-inch.
Yeah, minimum 110 or better.
Sure. And with 4-inch, I mean, I've done studies and tests on that before as well, and 4-inch certainly does reduce that number. Just because a bath fan says it's 110 CFM doesn't mean you're getting 110 CFM depending on how it's vented.
And then the HVAC technician typically points the damn thing in the wrong direction. Right?
Right. Yeah, where you have to do a bend or a turn and you're losing that airflow coming directly out of the fan. You're absolutely right. So yeah, flexible ductwork. Again, it does have its place in the industry. Again, for like attic applications, so on and so forth, there certainly is a good place for it. And if installed properly, if pulled properly, you know, proper bends with the flexible ductwork, it can perform well. Indoor air quality. How many homeowners, when they're buying a new home or even existing home, do they talk about indoor air quality? Do you hear about that a lot? Anybody? Some yes, some no. It's becoming more and more popular, I guess, in our industry. We're certainly seeing a lot more products being, you know, offered and accepted from homeowners that are educating themselves on indoor air quality. And what I mean by indoor air quality, you know, it's typically with the HVAC system, we're talking about the filtration, humidification, dehumidification, ventilation systems, UV lights, which we'll all talk about a little bit more here in further detail too. So there have been studies by the EPA that have stated that our indoor air is 5 times dirtier than our outside air. I don't know, I see that commercial, it seems like almost every week on that study with EPA, and A lot of different manufacturers stating that as well to try to push product, obviously. But there's a lot of studies out there that are showing indoor air quality is starting to drive up higher. Houses are being built tighter, so of course our infiltration in the houses are lessening, so it means that they're getting tighter and tighter without letting the house actually breathe. Hybrid duct system, hard pipe and flex. This is something too that we've seen a little bit more change in the industry. Typically flexible ductwork has the attributes to reduce noise and to reduce, you know, that static, so to speak, of that airflow coming out at a higher speed. So we've actually seen contractors install hard pipe up to where the boot would be connected with a small section of flexible ductwork. So again, it kind of helps cut down on noise and that air velocity coming out of the actual heat run. So it's a good way to call it a hybrid duct system. And then the equipment location we've kind of talked about as well, just the importance of making sure that that equipment is in an area that is going to, you know, work well again for that basement, work well for the home, work well for that duct system. If you have it on one end of the house and you're expecting it to push all the way to the next end of the house, you're going to lose a lot of velocity. You're going to lose a lot of your CFM. Now granted, there are ways to upsize ductwork to compensate for some of that, but you still reduce the performance of the system no matter what. Yeah, so duct sealing, one thing with like a Focus on Energy or Energy Star rated home. Has anybody ever done that before? Any builders here in the room, have they ever had a Focus on Energy test done before? Energy Star? Yeah. I don't know a whole lot about it, but that drives up your HERS rating, correct? Or drives down your HERS rating by having it a tighter home, tighter insulated duct system, as well as the insulation, window packages, so on and so forth. But duct sealing, certainly it's becoming more popular. I don't want to say it's going to become a code down the road, but I wouldn't be surprised if we do see that in a few years where that does become code because of the way everything is changing. There's a lot of different ways to tackle duct sealing. The most common way that you probably end up seeing is with a foil tape, not to be confused with duct tape. Duct tape is not meant for ductwork. So it dries out pretty fast and it doesn't have the adhesion properties that an actual UL listed foil tape has. But insulating, or excuse me, masticing is another option for duct sealing. Does anybody know what mastic is? Yeah, it's basically like a paste. You know, it comes in a little gallon tube. You take a paintbrush with it and you literally paint all the joints. So it's a little bit more of an involved process as far as labor goes, but the sealing properties and the sealing qualities of that are very high. So mastic is certainly used typically when you're trying to go for that Energy Star or Focus on Energy rated home, because mastic has the best attributes to be able to do duct sealing. That it what?
Messes up the ductwork.
It does. The aesthetics of it are certainly, yeah. And I got some pictures of showing it as well, and it's not as pretty, no question. AeroSeal, has anybody heard of that product before? Fairly new product of the industry, hasn't been around that long. Basically what AeroSeal is, it's a big machine that introduces a chemical, almost like it's a gum, kind of a gummy material. Xanther gum, I believe, is one of the properties in it, but it actually releases it into the ductwork, pressurizes the ductwork, and then where there's any cracks, gaps, seals less than about the size of a quarter, that property actually seals it up from the interior rather than having to tape it or use mastic. So it's kind of a new way to look at duct sealing. Very popular typically in the southern climates where air conditioning is run for 11 months out of the year. It's becoming very popular like in an attic application, so you don't have to go up in the hot attic when it's 130, 140 degrees and manually tape all that ductwork. So works really well. Good question. So we've done studies on AeroSeal. It's not cheap. It's not cheap to be able to do it. You know, we even looked at purchasing the equipment. There are some companies in Wisconsin that do it. I have one in Milwaukee, one in Madison area. We did an average test on it. Again, depending on the size of the home, depending on the ductwork, it's anywhere from $1,000 to $1,500 per house. So, there's certainly an added expense to it, but it does seal very well. Right. Yeah, I mean, there's a lot of people, like I said, typically in a retrofit application, you know, an existing home that are choosing to go that route much more than new construction. You know, tape is still used primarily as the #1 sealing factor for HVAC contractors at this time, or mastic. So, benefits of central return duct systems. So with the way that the building industry is certainly changing at more open floor plans, central return duct systems are becoming more and more apparent in the industry. And the main reason due to that is just lack of performance. When a HVAC system is typically installed, we're fighting with plumbing contractors, electricians, so on and so forth, to try to get enough areas for cold air returns, or even supplies for that matter, in the house to be able to adequately heat and cool the house. So central return duct systems are being used more and more, where there's an actual dedicated chase that's built for the return. So a couple of different benefits to doing that is you might have a chase where a closet isn't quite as big as what it used to be, but you're not running returns throughout the rest of the house either. You have a dedicated chase that comes up from the furnace from the basement with a grill location on first floor and second floor. I'll get to some slides kind of showing that. We'll come back to these. So this is a particular application for a central return grill located on first floor. So there's a chase for the ductwork that's built right here for us for that central return on first floor, and then that chase extends up to second floor as well. So all that's seen, typically the best location for those are, you know, hallways, rear foyers, areas, trying to keep it away from, again, bedrooms, living rooms, great rooms, to try to cut down on the noise volume. And then for each individual bedroom, there's a transfer grill that's typically located above the doorway. Has anybody seen this before? Out in Colorado? What was the reason for it? Building code? Okay. Yeah, and this is not to be confused with, you know, like combustion air grills either, for like laundry rooms, so on and so forth, with a gas dryer. This is the actual transfer grill that would be located for that room. Because obviously if these doors are shut and these are closed up, we want to ensure that we can still get a return pathway going through that grill.
Hence, you don't have to have a 2-inch gap underneath the door or something.
Exactly. So I forgot to bring it in. It was in my car, but Tamarack Industries actually makes a transfer grill that has like a cardboard property in it. So that way when you're cutting that transitional grill, because you'd have a grill on the other side of the wall, that cardboard actually acts as a light barrier and a sound barrier. So it really cuts down on that transfer of noise and air. That's a really slick system. You can't quite see it in this picture, but makes a big difference. So Tamarack Industries is the provider of that. Any questions on that? Yeah, it's certainly a lot less labor intensive. You know, if the chase again, you know, lines up with the floor joist downstairs to get first floor cavity up to second floor cavity, and then just doing those transfers, it certainly can be.
I thought that all the cold air returns had to be ductwork also, right? that use a cavity in the walls that chasing it?
Not yet. That's still being used. Yep. Panning or cavity wall returns are still okay. Right. And that's certainly the most common, aspect of a return air duct system is to utilize the floor joist cavities or even a wall cavity for that cold air return. So that's certainly the most common way to do return duct work. But again, central returns, by blowing up the open concepts, it's very challenging to look at getting adequate ductwork inside those homes because of that. So, and like you said, you had mentioned the cost perspective of it. There are some cost savings to doing it. So it's a different way to look at it. Certainly there are some some contractors that don't want to look at it because of the way their plan sets are set up, and that's completely fine. It's just another option to be able to offer out there in our industry to, especially on those open floor concepts, if performance is going to be factored into that, we want to make sure that we're offering all those options on the front end too.
I noticed that the grills are up high, so there's not a high-low like we normally see in the
Right. And one thing that we've toyed with as well, we've installed a handful of these types of systems. One thing we've actually toyed with on first floor is to going to a central return but mounting that low. Because again, you have that noise transfer when you're walking past it, where that grill is typically located at what? Head level, right? So we've actually experienced with that grill being mounted low, because that way the airflow, the blower noise, which no matter what type of system you have, even if it's not a central return, you're still going to get some of that air turbulence, some of that noise transfer through with that. But by keeping it low, you're still getting the same performance. It's just you're not getting the noise or the sound traveling through the ductwork as much.
Well, certainly newer furnaces with the variable speed motors have helped a lot.
Absolutely. Yeah, if you want a quiet system, the ECM drive blower motors, variable speed blowers, certainly the way to go. So one other thing, I guess, before we move on, to also cut down on the noise, that entire drop around that register and that grill is insulated from the inside. So there's a 1-inch barrier of insulation that's completely around that ductwork. And I did a study on a house that we did that kind of a before and after because we were testing it out. We did a decibel test before and after, and it was a matter of 17 decibels different after the insulation was installed. It makes a big difference. I have no way of gauging 17 decibels to give you that as an experiment, but 17 decibels is a lot. So another reason why central returns are being looked at, it also allows the architects and the home builders to be a little bit more creative with those plans, to not factor in the HVAC system, to only build a small chase or even tuck that in a closet area to be able to offer that same type of return in the home. And then HVAC system performance is increasing as well, because we're ensuring that if we have a system, a 2-ton air conditioner, so to speak, at roughly 800 CFM, we're actually being able to pull 800 CFM from that duct, from that cavity, because we can size it appropriately. There's no restrictions because you don't have a 2x4 wall that's cut out. You don't have that panning that might not seal 100%. It's all hard pipe that goes directly back to the HVAC system. So when we're doing our commissioning checklists and balancing checks, we're ensuring by taking static pressures, by taking CFM readings, that we're actually getting that full 800 CFM on those duct systems. So this is just kind of a picture of installation that we've done, and you'll kind of see that the mastic here as well. You can see on all these joints here, this is all those mastic joints. So it's all painted on with a brush. So again, it's very labor intensive, but the sealing properties are very good. And this is kind of showing the duct chase that goes up to those return grills that was showed here. There's a duct chase that goes all the way up from first floor, again, to second floor. One other thing you'll notice is the actual fresh air makeup right here. It's coming into the side of the return. So our makeup air, we're 5 feet from the blower, and we're also 5 feet from that first connection to the return. So we're not obviously having the worries of dumping that cold air that's pulling in from that fresh air, having that come back through the grill to actually feel that and to feel that temperature difference. As far as like fresh air goes, that varies. Our common way to get fresh air in would be, yes, you know, doing like a dedicated makeup air, you know, a scuttle makeup air like that. Sometimes we use like a butterfly damper, other times we use a powered damper. So the other way to do that is with a balanced mechanical ventilation system, HRV, heat recovery ventilator, ERV, energy recovery ventilator, which we'll talk about a little bit as well. This again is showing that central return that, you know, chases up and then goes again to the first floor as one dedicated hard pipe return. A lot of mastic. So I didn't stop on this slide yet. So this is another installation technique and method. This is actually used in Michigan a fair amount, this style of duct systems. And you know, we're always trying new techniques, always trying new ways to try to improve our systems as well as to give our builders the best quality, the best product that we can. And this is something that we tried, and this is, so it's a little bit different. You know, we have a main branch coming from the furnace here and then hitting to a T and then transitioning back. I'm not sure if you can see this, but that pipe's a 10-inch pipe there. That's a 10-inch T, so we have 10-inch going each way. Excuse me. So it's a different way to look at supplying the house with HVAC system.
It's a big hole in that roof.
It's a big hole. It is a big hole. So the contractor that we've used to do this with, they actually have the TGIs already bored out for us to accommodate that, because as you can imagine, cutting through that certainly can take some time. Well, it's kind of getting us to our different indoor air quality products here. So we use all Honeywell indoor air quality products. There's a lot of different manufacturers out there, but specifically we're just going to talk about Honeywell today. That's what we've had the best luck with, and that's what we're going to stick with. So Honeywell thermostats. Who here has gotten a lot of people interested in Wi-Fi technology? So certainly with the smartphones and all the technology that are out there, I can go in directly to my house, adjust my temperature, and I'll get a call from my wife shortly thereafter. So, but it's a really neat way to be able to monitor not only your temperature, but certainly one of the added benefits to it is people that travel a lot. So one good benefit to that is you're always knowing what the temperature is inside your home. And if it drops below a certain temperature, it'll give you an alert directly on your phone, so that way you can catch it in the event of a problem. So I'll give the example. This actually just happened this week. My brother, who lives in northern Wisconsin, had a toilet supply crack on his toilet. And down below where this happened, his house is 11 years, so it's kind of like a freak thing, but down below it where this had happened is where his water heater was, and he had a Honeywell Wi-Fi water alert system down here by his water heater and by his sump pump. So once this water actually started hitting this sensor, he was at work half an hour away. It alerted him directly on his phone that there's a leak in his house. So he was actually able to call the neighbor, go over there, found that there's water literally spraying all over the place inside his house, and was able to actually correct the problem. So if he hadn't have had that little sensor, granted it was still a period of time where there was a lot of water and a lot of damage that occurred because of it, but he works 12 hours, he's a paramedic. If he would have worked been home after 12 hours, his whole house would have been completely flooded. So, very costly. That would have been an awful, awful tragedy for sure. But again, kind of the same thing with Honeywell thermostats with the Wi-Fi technology and the abilities to be able to do that.
How many homes have you been able to do residential jobs that you do?
The Wi-Fi thermostats? About 25% right now.
So you're selling it?
What's that?
You're selling it?
Yeah, yep. So I mean, that doesn't sound like a very big percentage, but you know, obviously there's a significant cost of those styles of thermostats compared to a standard programmable thermostat. So
We just had our furnace replaced at our church, and they put in all new lyrics all the way around it, and they're all programmed on my phone and the pastor's phone.
cool.
So we have the whole church programmed as to when the air conditioning goes on, so I don't have people yelling at me.
Right.
So it is pretty cool.
It
It's
is.
a little bit to get them set up, but it was pretty awesome.
Right.
It's all here, so.
Yeah. And the geofencing. So, heard of Nest thermostats before? You know, it's pretty common in the industry. So the Lyric works under like what's called geofencing. So it monitors and tracks your cell phone. So I'll give you the example. If you're a half an hour from work, that thermostat knows that you're roughly a half an hour from work. So as you start to drive back home after you're done working, that alerts your thermostat in your house to go back to that temperature that you have it set to. So when you're away, if it's at 75 degrees, but you start heading back home, it's going to say turn it down to 70. So it alerts you. There's a feature. You can turn that either on or off with the Lyrics. You don't have to do that, but excuse me, there's certainly some added benefits to that. But Honeywell offers, you know, the basic non-programmable heat and cool all the way up again to the Lyrics 9000 series, which is a color touchscreen thermostat, 8000 series, so on and so forth. So a lot of different products that they have to be able to fit individual needs.
Biggest problem I'm bored with this stuff big time, but the biggest problem I have is I'd say 80% of our people are over 60.
Mm-hmm.
Building a dream home, all that kind of stuff. And they have a hard time operating the stats. They
Right.
just don't like them, especially the riders. I want to sell it.
Right.
Think about the old Honeywells.
Right.
And so that's been the biggest problem. We put in this triple $300 stat, and
Right.
they call up and say, take that thing out.
Right.
It's a tough one.
It is, absolutely. And that's part of the reason that Honeywell actually designed that Lyric in that round, because you can actually turn it. So, yeah, right. So, yeah, like everything, you know, the technology, you know, they make the standard up and down arrows with the large displays for the easy to read, you know, so on and so forth too. But Honeywell's got a lot of great products out there. So humidifiers, that's another thing that, you know, typically when you hear of humidifiers, you know, obviously that's introducing humidity into the air during the winter time. And again, in Wisconsin, when our heating seasons typically last 7, 8, 9, sometimes 10 months out of the year, it seems like, being able to introduce that humidity certainly is important. By raising that humidity in the house, it actually makes your home feel warmer. So you may be able to even lower your thermostat setting anywhere from 1 to 2 degrees when the humidity is set properly. Average setting on a humidifier is 30 to 50% relative humidity. Again, that's going to change depending on the home, how many showers people take, cooking. You know, large families are obviously going to produce a lot more moisture inside that house than a family of 2.
We found that using these new furnaces, that people don't need the humidifier because you're not superheating the air.
Mm-hmm.
When you try the furnace at 30% rather than super driving out the air, that's been a real big deal.
Absolutely.
Especially found that did in my own home.
Mm-hmm.
Humidity's hanging in.
and by tightening up your house as well. You know, again, better insulation factors, better windows. My old house up in northern Wisconsin, we replaced all the windows, and we did an insulation package as well in an existing home. Before that, my humidifier ran all winter long. After I did those improvements, new windows, new insulation, I no longer had to use my humidifier, just because normal, you know, family of 5, showers, cooking, turning on the faucets, having a fan run continuously, I was able to produce enough moisture inside my house that it wasn't needed. Absolutely. Right. And there's a lot of different styles. The one on the right is called a powered humidifier. The one on the left is a bypass. The powered humidifiers actually have a fan that helps force the humidity throughout the duct system. So it helps atomize the humidity a little bit better, breaks up the water molecules, breaks up the humidity a little bit better than the standard bypass.
Any opinion on Honeywell versus HVAC?
You know, we've used both. As far as the products go between Honeywell and Aprilaire, I think they're very comparable. I think they both make a really good product. For us, it just made more sense to do it because of the service that we were able to get from Honeywell. We've just had second to none service with Honeywell, and they do a really good job for us. So, but Aprilaire is kind of the name out there that everybody associates with humidity, right? So it's not anything we battle. The products, you almost set them side by side. I mean, there's a lot of similarities between them. Dehumidifiers. So this is something, again, in the industry that are becoming more and more popular too, tying these into duct systems, HVAC systems, is to get a whole house dehumidifier. So these can be utilized as a standalone model, or they can be ducted directly into your return and your supply to help pull the moisture, pull the humidity out of the air, which helps reduce the air conditioning run times. So we've also found that by adding and installing whole house dehumidifiers in line with the systems, we're actually able to reduce our cooling load in the home because we're removing that much more humidity. So when we're doing our manual J calculations on those houses, we're actually seeing we're reducing our overall tonnage on our air conditioning systems. And these, Honeywell makes them all the way from, you know, standalone whole house units up to, you know, light commercial applications as well that can remove literally hundreds of pints per day of moisture. And one of the last things here, ventilation systems. I know that question was asked, you know, whether a makeup air or a Scuttle fresh air makeup is used. This is another way to tackle ventilation in a house, is with a HRV, heat recovery ventilator, or an ERV, energy recovery ventilator. So typically heat recovery ventilators are used in more northern climates, you know, such as Wisconsin. The way that they are able to exchange their heat and recover the heat, because our heating season is longer than our cooling season. And then just vice versa, ERVs are typically used in southern climates, which are better for dehumidification properties, the way that their internal core and the way that they exchange the air are set up. Have anybody seen ERVs, HRVs installed in houses today?
We had it installed, the biggest problem then is keeping the intake air clean.
Hmm.
The vent gets clogged up with leaves or whatever,
Mm-hmm.
and people don't take care of it.
Right.
Other than that, they look good.
Yeah. And just like with anything, there's certainly maintenance to having a mechanical system like this in your house. There's filters that are inside that actually help filter and pre-filter the air before it hits the actual heat exchanger core as well. So a lot of different products. There's again, there's a lot that goes into HVAC as a whole. You know, right on the design work, up front in the installation, you know, all the way to, you know, the commissioning and the setup of the systems by, you know, ensuring proper static pressures are taken, proper combustion is taken at the unit, where the systems are actually tested out versus just having it set to manufacturer specs, turning the thermostat to ensure that the system works, and then walking away from it. So, so that's all I have for you guys today. Questions?
Yeah, you didn't discuss air exchangers?
Yep, like this?
No, I meant for changing the air in the house, not necessarily.
Oh, okay. You're right. Sorry. Right there. Thought it was on my last slide. Sorry. Yeah, so filtration is certainly another important quality here as well. You can get a standard media filter, that's a 4 or 5 inch media filter, all the way up to the electronics that, the bug zapper, so to speak. It kills and neutralizes all the things that are inside our air as it's passing by the collection cells in here. Again, with indoor air quality and again tightening up the houses, that's certainly an area that is becoming more focused in on. And again, this particular system shown here is a electronic air cleaner designed by Honeywell. So there's a media filter that's installed with this on top of cleanable or washable filtration media as well. So there's obviously electronics that run to this to help zap, so to speak, kill mold spores, pet dander, pollen, all that other stuff that's circulating inside our house. Go ahead.
Do you do a lot of zone systems in forced air, or have you studied the efficiency of that compared to non-zone?
Well, zoning as a whole, typically you see that more in like a larger 2-story home, for instance. That's when I think that we see zoning becoming a lot more popular, is just guaranteeing more of that comfort. As far as the efficiency and the energy that's actually used, that's kind of a misconception that zoning is going to reduce your overall energy efficiency, because you're still conditioning the entire envelope, no matter what. It's just where you're actually conditioning it to. So zoning is certainly becoming more popular. But again, we typically see zoning in those larger 2-story homes. One thing that can actually help deter zoning, or one thing that will actually hurt zoning, is what's called micro zones. And I'll make the example. If you have a 2,500 square foot ranch, but you want to have your master bedroom set on one thermostat. Well, between the bedroom, maybe the walk-in closet and the bathroom, you probably only have 4 heat runs as an average. So by zoning that master bedroom, depending on the piece of equipment that's chosen, sometimes again you're overheating or overcooling those particular areas. If the furnace is just a single stage piece of equipment, it's coming on at full blast trying to maintain that master zone, which might only need, say, 10,000 BTUs, but the furnace is kicking on at 60,000 BTUs. So there's ways around it to put bypasses in, which is what we do as a standard. But no matter what, you're still heating that system. You're still conditioning that system to try to accommodate for a small zone. So not to say it can't be done, because it can, but there's a lot of design factors that go into doing that. And that's certainly when upgraded HVAC equipment is important to consider. Looking at 2-stage equipment, variable speed technology, even variable speed technology on our conditioning or condensing units outside. So,
How many zones can a furnace provide?
it depends on the actual zoning panel, what controls the actual zone dampers to open. There's like Honeywell, they make up to a 4-zone damper as their standard, but there's ways that you can combine that on to have multiple zones or more than 4 zones on one specific system. But typically there's a lot more ductwork, there's a lot more design that has to go into doing it that way. Arzell zoning, has anybody heard of Arzell zoning before? Instead of actually having zone dampers like a traditional duct system where you're installing the zone damper in a rectangle duct system, Our Zell actually has individual dampers for each heat run throughout the house. So let's say if you had 30 heat runs, throughout the house, you can literally have a damper for each individual heat run in the house. And that particular system can actually have 12 zones. So, not that you would ever necessarily do that, but it is possible.
Does that mean you have 12 different thermostats?
That is correct. That'd be pretty confusing, wouldn't it? Does that help answer your question, or?
Yeah, when you say manual J calculation, so is that the same thing as I think of the race check?
It's very similar. It's a different program. Manual J calculation, that's typically provided by a software program called like RightSoft is one, Elite is another, ACA, American Contractors for Air Conditioning. So, but yeah, that manual J calculation is similar to like a res check or a REM rate. Basically, it's taking that full BTU load of what that house is to be able to determine what piece of equipment you need to install.
Any opinions on manufacturer types?
As far as brands go, oh, that's $1 million question. Personally, I've installed just about everything out there. I mean, literally just about everything out there. What I found and what the industry, has really started to state, if it's installed properly from day one, you should be fine. Because of the fact of the matter, the most important day in the life of that system is the day it's installed. It's all in the upfront design work. If it's designed properly, the ductwork is set up properly, it's sized properly, and then it's commissioned properly. You could take a $2,000 furnace and do all those things, install it properly, commission it properly, have a properly sized duct system. That system's going to perform very well for many years.
So we're putting our trust in the HVAC contractor, basically.
Mm-hmm.
Me, as an average builder, I don't know your world.
Mm-hmm. Yeah, you are. But it's important to know some of the stuff on the front end to ensure that, again, the end product, the house that you're selling, that homeowner is going to have a good performing system. So by doing that manual J or that upfront calculation is at least going to make sure that your equipment is sized right. But then it's the ductwork, making sure that that's sized right. And what I feel is the most important is the commissioning, because you need to check combustion. You need to be checking your airflows. You need to be checking your static pressures. So I'll get to a slide here where it kind of shows some of that stuff. It's kind of hard to see, but there's a little hole here in our exhaust pipe, and then there's a hole up here, there's a hole in the cabinet here, and there's a hole in the return on this side. So we're checking our static pressures across our entire system. So we want to know what our static pressure is here, or our airflow resistance across our filter. We want to know what it is across our furnace. We want to know what it is across our air conditioning coil. So that way we can ensure that our duct system is sized appropriately, and then we're also setting up the airflows appropriately based on that house.
But what interest do you have to check your own work? You're not going to spend extra money or time changing it once it's installed.
Yes, we do.
It's the cat watching the hen house.
We do.
How do I know as a builder that it's functioning the way it should?
Again, that's getting back to the trust of your HVAC contractor. And I guess I would ask the question, if you go down to your system and you're not seeing those specific holes where they can actually check your delta T's, check your combustion, check your airflows, what are they doing? They're guessing. Or they're setting it up based off of how it came from the manufacturer, maybe adjusting their airflows to match the condensing unit outside. But without proper testing, it'd be like me going to the doctor and saying, I've got heartburn. Well, he says, you're having a heart attack. Well, how does he know that unless he hooks up an EKG, blood work, so on and so forth? There's a lot of testing that has to go in to be able to determine that.
Is the state getting to a point where the balance report is required to turn into the building inspector?
I believe it is. I know we perform a balance on every single house.
In the commercial world, that's what
Mhm.
But in residential, how do I trust that my HVAC contractor's installing it?
Mhm. Okay, that's a good question. I know all municipalities, all subdivisions are a little different. Every county is even a little bit different. So, to my knowledge, a CFM or an air balancing report for most municipalities do need to be turned in to pass inspection. Any other questions?
How many mini splits are you doing?
Oof. Not as many as not as many in new construction applications. Again, mini splits are like Mitsubishi, Sanyo, Fujitsu are the kind of the big players in that game. They're great for that bonus room above the garage where it's very challenging to get ductwork in, or the mother-in-law suite. We see that fairly common, used for mini splits, but I think in the industry that's an area where it's growing. I mean, in our HVAC industry as a whole, that is blowing up. I know Mitsubishi had like a 30% increase last year alone. So I mean, that industry it's blowing up.
Well, with the advent of a much more high performance heat pump
Yeah.
in the system,
Yep.
it seems like a good idea.
Yeah. When they're being able to get by with doing that type of a system than a traditional ductwork system, because the homes are getting so tight, so energy efficient.
And the framing is getting more challenging.
Yeah.
Yeah, exactly.
Right. Any other questions?
Good review.
Well, I appreciate everybody coming in. Thank you very much for your time, and hope you got something out of this. Enjoy your day.